So in this and the next few videos, we're going to talk about a simplified version of multiple inheritance in Python. And to motivate for that, let's look at another example of inheritance. So we all know what pictures are, audio files, as well as video files. So all these are what's called media files, and they have many different properties, but at least the following ones. So all of them, pictures, videos, and audios, they would possibly have creators and the times that they're created and the size of the file. And for pictures, it would have a dimension, right? The width and the height. Now for video, it will have the width and the height and also a duration, how long the video is. For audios, there's no width or height, but it does have a length as well, so the duration. So how will we design a inheritance hierarchy for media files? So one way to do it is like this. We're going to factor out all the common properties or attributes, the creator, the size, and the creation date. And we're going to put it in the common ancestors for all these files. And then we're going to have the audio class that inherits from the file class. And it's going to add the duration property. Pictures is going to add width and height. And for video, it's going to add the duration, width, and height properties. Now, what could potentially be a problem with this? Well, it's kind of, you can see that video actually has both the attributes from audio as well as the attributes from the picture. So can we actually do better? Can we, let's say, for example, actually have the video class inherit from the audio class as well as the picture class so that it does not have to define any of its own attributes. And if we do that, we'll end up with an inheritance hierarchy like this. Now, this example is a little simplistic or even a little contrived because a video is not just a single picture, right? It's usually a sequence of pictures. But let's, for the sake of discussion, just assume video is just a one picture slideshow with kind of audio for now. And also another simplification that we'll do for now is that we'll focus on the bottom part of this hierarchy. So for now, we will not take into account of the common and the base class at the top, the file class. Okay, so just this part, audio, picture, and video classes. And let's first define the audio and picture class because they are going to be the base class for video. All right, so I've defined it here. So for audio, it has a duration for, so we create the duration attribute, and for the Dunner string method, we are going to just print out the audio duration. Let's ignore the play for now. And for pictures, we have the width and the height, and this is what we are going to do for the Dunner string method. And again, let's ignore the show for now. So now we can instantiate audio. And to instantiate audio with the duration, I'm just going to use this time delta type that's from the datetime standard package. So it just allows us to easily say specify an hour. And we are also going to instantiate a picture with the width and the height, and we're going to print it out so we can see that so it works, audio and with the duration and picture with width and height. So nothing new so far, but the video class is going to be more interesting because it's going to inherit from two classes now. So to do that, here's how we define the video class. In the parentheses after the name of the class where we specify the base class, we can specify two base classes, audio and picture, that are separated by comma. And that's how that's the syntax for inheriting from multiple classes. And now, so what do we do in the initializer? Well, for the video, we need duration, width, and height. So we get that. And so how do we call the the base classes initializer, well, so maybe this is one attempt. So we would imagine that audio's initializer is the one that takes duration. So we'll call super init and pass it the duration. And then the pictures initializer is the one that needs the width and height. So we'll pass those two parameters to picture initializer. So the question is, would that work? Well, we can just try it, and nope, it does not work. And what is it complaining about? It's this line. So in this line, the second super than the init, it complains that init, it wants 2 positional arguments, but 3 were given. Okay, what happened there? So what happens is, for the first super, then the init call, it will try to find the init method in the base class, and the order it looks in the base class is actually it start looking in audio first, and when it looks at the audio and it sees the init method, well, that method takes a parameter duration, and here it supplies a parameter, an argument duration, so that's fine. So this call actually works. So that's why in this class message, it's a stack message, it's actually not complaining about this line. Now, when it gets to the next line, it will do the same thing again. So because it's the same call, right? Super than the init. So again, it's going to look in the parent for a method called than the init, and it starts again with the first class, first parent, which is audio, and it will find the audio than the init method again, which takes a single parameter, but here it supplies 2 parameters. So it's like, okay, I really don't know how to pass 2 parameters into 1 parameter. So it complains here. And another way to see this is that Python really kind of just finds parameters by name only. So when we say dunder init, it really only always finds the same method. The number of parameters in Python does not matter. Only the name matter. And that's where our trouble is. All right, so how do we fix that? Well, one way to fix it is that if kind of just relying on super, it doesn't find the right base class, then we can actually explicitly dereference the base class, in this case, picture. Now, if when we call a instance method by dereferencing the class, then the instance method really kind of requires an instance, right? So in that case, we have to explicitly supply the instance for this instant method to work with. And in this case, it would be the video, the instance of the video itself, right? So we have to say self explicitly here. And so by the same spirit, let's do the same thing for the dunder string method. So the first super dunder string is going to call the audio's dunder string method. And so this second one, the way it is written, it will also call the audio dunder string method. So we'll have to say explicitly say this second one should use the picture dot dunder string, and again dunder string method, they all require an instance. So in this case, we have to explicitly supply an instance. So okay, let's see if that works. And when we run that, and hey, look at that, it actually does work. It fixed our problem, or at least so it seems. Now I have a little exercise for you that in our current example, the multiple inheritance, we put the audio as the first class, or first base class, and picture as the second base class. what if we switch the order? What if we put picture first and audio second? What do you think is going to happen? So what happens if you try this? And I'm actually going to try this now. So audio, and what used to work no longer works. And let's actually look at which line it's complaining about. So now it's complaining about the first call, super dunder init, and it says that method actually requires the two positional argument. So it's right now we're supplying only one, so we're missing one for height. And the reason for that, I hope that after the previous explanation, you can see that because we put the picture as the first base class, then the super dunder init is going to find the dunder init definition in the picture class, which requires two parameters, whereas we are supplying only one argument here. So that's why now this is not happy. So to fix this problem such that the order of the base classes does not matter, we can do what we did previously, is that we can explicitly dereference the base class to call its method. Now again, we have to supply an instance, and so the same idea in the dunder string. So we're going to explicitly call audio and supply the instance here. So all right, so let's see if this works, and it does again. And just to show you that the order does not matter, I switch the order and it still works exactly the same way. So for now, when we want to call a methods that exist in multiple base classes, we should explicitly dereference the class to call those methods. So that's the rule that we'll follow for now until we study something that's called an MRO, but it's a topic for later in the class. And also this approach, this way of explicitly dereferencing the base class to call its methods, it's, I believe, it's used by C++, so it's not a bad way by any means. So let's recap and think a little bit about why we had so much trouble with the dunder init method. Well, that is because most classes have the dunder init method, right? So when a single class inherits from multiple classes, and in combination with the fact that Python only finds a method by its name, then when there are multiple methods with the same name, then there's this name clash or name conflict, right? And when we just kind of say super dot dunder init, then we may not find the right dunder init method that we want to call. So that's why we kind of have to explicitly tell Python which base classes dunder init method we want to call. So that's for methods with name conflicts. What about methods that do not have name conflicts? How do we call them? Well, so the example here is, so for audio, I have a play method that would play the audio. In this case, it will just print out a message. And for pictures, we'll have a show method that would presumably show the picture on your output device. Again, here we just simulate that by printing a message. So in the video class, then we'll define a play method that would both show a picture. Remember, our video is a slideshow with one picture. It will show the picture and also play the audio. So now because we're defining the play method, and to show the picture, we'll call the picture dot show. And so we're not overriding any method here. So our rule to call a method that is now being overridden is just to use self dot, right? So that's what we do here. Now, because for the audio dot play method, because we are defining we are overriding the play method, we obviously cannot say self dot play here. Otherwise, it's just going to infinitely or recursively call itself. So we have to then here say super dot play, and that would call the audio play method. So let's see if this works. I actually instantiate the video here, and I say video dot play, and it does the right thing. So it says that it's showing the picture, and then it's also playing the audio.